So we are going to start talking about linear functions. Chapter 5 is the last stuff that will be on your midterm. So this is the last thing we'll cover before we go back to review. Keep in mind that for the midterm, it's all 5 chapters. All right, it's not just a chapter 5 test. It's chapter 1 through 5 test. We'll do a day of review for each chapter, but chapter 5 we'll probably review for the shortest time since we'll have just done it. All right, so chapter 5 is about linear functions. And when you take a look at these 3 graphs, the question here says, identify whether each graph represents a function, explain, and if it does represent a function, is the function linear? So there's actually 3 parts that are going on in there. So when we look at these, the first thing you need to identify is if it's a function. And remember, think back to when we talked about functions. We talked about them using tables, using mapping diagrams, and using ordered pairs. How did you identify if it was a function or not? How could you tell if it was a function? If there was not more than one x value. Very good. So the x cannot repeat. So there is no repetition in your domain. Could you have more than one range, more than one y value?
Yes.
Yeah, you can have plenty of the same y values. It doesn't matter. But you can only have one x value if it's going to be a function. When you're looking at a graph, the way that you can tell is if it passes the vertical line test. And the vertical line test means if you draw a vertical line, it only touches the graph one time. All right, so if I draw a vertical line anywhere, it's only going to touch the graph once. Vertical means what? Up and down. So if I start drawing up and down lines here, how many times do these up and down lines cross this red line right here? Only one time. So is this a function? Yes, this would be a function because it passes the vertical line test, which again means if you draw a vertical line, it's only going to touch the graph one time. Is this b right here, is this a function? Yeah, does it ever touch more than once? No, it just goes through the graph one time and keeps going. So yes, that is also a function. So we say A is a function, yes. And we would say to explain it, all you'd have to say is it passes the vertical line test. All right, B is a function, yes, because it also passes the vertical line test. What about C? No, why not? Yeah, if I draw a vertical line, how many places does it touch this red line? All the places, right? Every single point it touches. So then no, this is not a function. And then the last question says, if it is a function, is it a function that is linear? So I don't even need to worry about C because C is not a function, so I don't need to answer that question. But I do need to answer that question for A and B because both of those are functions. So looking at A and B, which one of those is linear or both? Which one of those is linear? A is linear. B is not. Why not?
Because linear means like straight line.
Linear means it makes a straight line. What is B?
It's a parabola.
A parabola. Does anybody remember, this would be good if anybody gets this. Does anybody remember what equation looks like a parabola when you graph it?
An equation with absolute value.
That's a linear one.
Oh, wait, no. An equation with absolute value.
Desiree? When it has a squared in it. Perfect. When it has a squared in it. Brendan, you were really close. You said absolute value. The only difference with absolute value, it makes a V, not a U. So it's not a parabola, but that was good. Both of you guys, nice job on that one. So this is a function, yes, for A, and it is linear. For B, yes, it's a function, but it's not linear. All right, so yes, it's a function, but it's not linear. And again, how do you tell if it's a function if I give you the graph of it?
The vertical line.
Vertical line test. Do you actually have to draw vertical lines? No, you don't have to. Okay, you can just you can use your hand or your finger as a vertical line. If you can run your hand down the graph without touching it more than once, then it passes the vertical line test. How would you be able to tell that if I just give you a list of ordered pairs?
Graph it.
Ashley?
Graph it.
You could graph it, absolutely. Okay? Is there another way you could do it? Brendan, what do you think?
Just look at your x value.
Okay.
See with more than one x.
Okay, so first of all, to see if it's a function or not, we just have to look at our x values. Good. So we just look at our x's, and that tells us if it's a function. So right here on the left side, let's call this one number 1. In number 1, is that a function? Yes. Why?
Because x is not repeated.
X does not repeat. Therefore, yes, this is a function. All right? Yes, it's a function. Can you figure out if it's linear without graphing it? So Ashley says graph it, which you absolutely can do. But I'm lazy. all right? And it is a long process to draw a coordinate plane, and I don't want to do it, all right? And I have a feeling some of you guys might also not want to do it. Could I do it? Yes, you absolutely could do it. I'm feeling a little bit lazy. I don't really want to do that. So is there a way that I could do it without graphing it? We already know we can find out if it's a function just by looking at the x's.
Use negatives.
What do you mean?
Like -2.
Okay, we already did that.
Because
Why are you saying that, though? Tell me why you think we should use negatives.
when you use negatives, you're like starting over.
Oh, okay, so you're telling me that you would be able to identify if it's a parabola, because if you use negatives, what happens with the numbers?
They go to the other side of the graph.
Yeah, so it makes some kind of a pattern, right? Okay, so that might work, but that's kind of a lot to remember. And it works only very specifically for parabolas. You wouldn't be able to identify absolute values and things the same way. So is there another way I could do it? Go back to what you guys told me. What is a linear function? Makes a straight line. What does that mean it makes a straight line?
It's constant.
What's constant?
It's proportional.
It's proportional? What do you mean by it's constant or it's proportional?
Like, I'm thinking you can plug in a number, and if you plug in something, you probably figure out.
Yeah, absolutely if you had the equation. But if it's linear, what that means is it has a constant rate of change. Or what we call that in a graph is the slope. Has everybody seen the slope before? What does slope mean? Rise over run. What does that mean? Brendan's not the only one here. I know you guys.
You go up.
You go up and then you go over, right? You're like figuring out how much you go up for how much you go over. How many of you guys have ever walked up a handicap ramp? Walked up like a ramp into a building like a handicap ramp? Okay. Are those very steep or not very steep? Not very steep. Why? It would be mean if you made a handicap ramp really steep, right? To try to get a wheelchair up a handicap ramp if it were really steep. All right, so the slope of that is really shallow. It's a shallow slope. What about a mountain? What about like the Rocky Mountains? Those are really steep. It would be hard to walk up them. Sometimes you'd have to climb up them because you couldn't walk. So slope is how steep or not steep something is. So to figure out if it's linear, you want to know if the slope or the rate of change will be constant. So to look at that, all you need to do, rather than graphing it, which you could absolutely do, is say, is it the same change in my x column and the same change in my y column? So look at this x column. How do I go from -2 to -1? How do I go from -1 to 0? From 0 to 1, 1 to 2. What's the pattern there? What's the pattern there? Again, there's a lot of people in this class. Plus, does it work every time? All right, so is that a constant rate of change in the x's? Yes. Is it a constant rate of change in the y's? How do I go from 7 to 4? How do I go from 4 to 1? How do I go from 1 to -2? And -2 to -5? So is that a constant rate of change? So then we would say that this is linear. Because there is a constant rate of change in the x's and in the y's. All right, so to tell if it's a function, you just look at your x's. To tell if it's a linear function, you look at the x's and the y's. So again, taking a look at number 2 then, I'm just going to look at my x's. Is this a function? Yes, it's a function because none of them do what? None of them repeat. Yeah, they don't cross over each other. They don't do the same thing. All right? Now, what's the rate of change here? Still +1, same as the last one, right? This is still a +1 rate of change. What about my y's? How do I go from 6 to 3? How do I go from 3 to 2? Okay, I don't even need to keep going because is that a constant rate of change? No. So what would I say? Not linear. So yes, it's a function, but it's not a linear function, which means if I graph it, it won't look like a what? A line. So you can absolutely draw a coordinate plane and graph these if you want, or you can just find the rates of change, whatever is easier for you. All right, whatever makes it easier for you. So I want to tell whether each ordered pair here satisfies a linear function. This looks confusing for me as a set of ordered pairs. How else could I organize this? In a table? So I'm going to do a table of x and y. What are my x's? And what are my y's? Okay, so the first thing I need to do is tell if it's a function. Is this a function? Yes. How do you know that, Montrell? Is it a function? The domains don't repeat. So it's not, and then over here, Montrell, you said, yes, this goes up by what? Plus 3, plus 3, plus 3. What about over here? Minus 1, minus 1. So is this a linear function? Yes. So on top of being a function, it is also linear. All right, try the second one at your seats. Try B at your seats. Is this a function?
No.
Is it a function? Yes, it is a function. How do you know that? The x's do not repeat. So the x's don't repeat. All right, I'm going to put this in negative 10, negative 5, 2, or 0, and 5. And then my y's are 10, 4, 2, and 0. And then how do I check if it's linear? If there's a constant rate of change. What's the rate of change for my x's? Plus 5. And it works all the way down? What about my y's? Minus 6, minus 2, minus 2. Okay, so is that a constant rate of change? So we would say, yes, it's a function, but not linear. All right, so yes, it's a function, but it's not linear. All right, questions on those? Okay, go ahead and try them at your boards. Which one of those were not linear in the top row? 15, because it curves, right? What about 17? 17 is weird because doesn't it look like both of the parts of that are linear? So how come that doesn't count as a linear function then? Okay, because we can only look at one part, and it does not have a constant rate of change. This one's going down, this side's going up. So the rate of change cannot be constant, therefore it is not linear. Good. All right. How would you graph a linear function? How would you graph a linear function? Brendan, what do you think?
Probably a straight line.
Yes, it's probably going to look like a straight line. Good. Okay, how do we graph any function? What do we do? Think back to your chapter 4 quiz. How do you graph a function? What do you have to find first? Yeah. What do you have to do first? Plug in which numbers? Any old numbers you want to plug into, right? What did I say you should plug in? All right, and you plug those in, and that gives you a set of what? X numbers and a set of Y numbers, and then you do what with those? You plot those. Okay, so you plot those. All right, so when I plug in negative 2, what does that give me? Negative 2 plus 3. Don't all shout out the right answer at once, guys. Negative 2 plus 3. 1. All right. Ooh, that was scary. All right, -2 plus 3 is 1. -1 plus 3 is 2. 0 plus 3 is, all right, 4 and 5. The best thing with a linear function is that if you pick the 5 numbers for x that go in order, if you find a pattern in your y's, you know that pattern has to work for all of it, so you can just keep going with the pattern. So as soon as you saw 1, 2, 3, you could do 4 and 5 without doing any math. All right, and then how do we finish it? By graphing it. So my first point is -2, 1, so I go left -2 and then up 1. So there's my first point. All right, what's the next thing? All right, thank you, Matthew. All right, so here's my linear function. Since I know this is a linear function, if, for example, I had graphed this point wrong, this third point, because a lot of people want to graph it over here. They mix up their x and their y, and it went like this, you know that it would be what? Wrong. You know you would be wrong because you're graphing a linear function. So if yours is not a straight line, you must have made just like a little mistake somewhere. So go back and check your work. And typically people make mistakes in either the negatives or with the 0, 1. All right, when they're graphing their 0. Okay, so I want you guys to graph these 3 at your boards. Go ahead.